Hello.
Yes, sir.
Did you copy the ground state and excited state?
No, sir.
Okay, let me write again. So,
सर ब्राइटनेस कम है.
brightness कम है. हमको पीछे. They need bright teachers. Students are not bright. John Helak Puchand. Now it's all right?
Yes, sir.
Okay. NiNS3 whole 4 2 plus. So our nickel atomic number is 28. 4s2 3d8, and here nickel oxidation state Ni plus 2 is your 26, 4s0 3d8. Now ground state excited state. Ammonia is a stronger ligand. Okay. So when ammonia approaches to the metal atom, this electron get paired up against the Hund's rule of multiplicity. So in excited state, so here D, 3D, 4S, and up to this 4P. So hence hybridization is here. So D, S, P2. The ligand will take the position of this D, S, P2. So hence hybridization is here. Is it visible?
Yes, sir.
DsP2, it is square planar. And number of unpaired electron n is equal to 0. So hence it is diamagnetic. Mu is equal to n into n plus 2 square root Bm. So n is equal to 0 means mu is equal to 0. Is it clear to you?
Yes, sir.
So anybody's doubt, you can ask me right now. Did you copy this?
Yes, sir.
Now you compare. So NiCN whole 4 2 minus Ni so same way nickel 28, 4s2 3d8, nickel 2 plus, the oxidation state of nickel here plus 2, 26, 4s0, 3d8. Now, ground state, so whenever cyanide is a stronger ligand or weaker ligand? Yes. Cyanide. Ruchi.
Don't know, sir.
Okay. Cyanide is stronger ligand. Remember. Cyanide is a stronger ligand. Cl minus. The same way as NiNH3 whole 4. So whenever in excited state, so this electron will come over here. So again hybridization is your DSP2, it is square planar. Same as your NiNH3 whole 4. Copy it. Copied.
Yes.
It is same as here NiNH3 whole 4, 2 plus. Now we will come for next NiCl4, 2 minus. Should I rub this one?
Yes, sir.
Now come for this one. This is Cl4, that is a weaker ligand. Cl minus is a weaker ligand. Now the same, the configuration and configuration of its ion in the ground state, in the excited state will be different. Now, 4 ligands are coming. 4 ligand. Whenever 4 ligand, this will be the position of the ligand. Ligand will supply pair of electron. So hence, hybridization is there. sp3 hybridization. This is your tetrahedral. And number of unpaired electron is 2. Mu is equal to how much? root, this is the root over n into n plus 2 square root. Number of unpaired electrons are 2. So 4 into 2, that is the root 8 Bn. This is about tetrahedral complex NiCl 4 2 minus. Is it clear?
Yes, sir.
Anybody's doubt, you ask right now.
सर उधर इलेक्ट्रॉन पेयर नहीं होगा
कहाँ?
एक्साइटेड स्टेट में
In excited state, these two electrons will remain here. So it cannot be paired up against the Hund's rule of multiplicity. So therefore, it goes for outer orbital complex. It is spin free. Since electrons are, this is spin free or high spin. We'll go to the next page.
Yes, sir.
Just you remember, one important point is this: for stronger ligand, pair up the electrons against the Hund's rule of multiplicity, as I have taught in NiNH3 whole 4 and NiCN whole 4. But in case of NiCl4 2 minus, so this becomes tetrahedral. Hybridization is a sp3 hybridization. Could you follow or not?
Yes.
सर वो स्ट्रॉन्ग फील है वीक फील वो पता कैसे चलेगा
हाँ वो वाला दैट इज स्पेक्ट्रोकेमिकल सीरीज एक तो देना पड़ेगा. सो व्हिच इज स्ट्रॉन्ग एंड व्हिच इज वीक. अभी मैं दे रहा हूँ. राइट ए स्टार पॉइंट. Weak ligands or weak field ligands. I minus, Br minus, Cl minus, F minus, till water. Now strong field ligand are ammonia, Cn minus, Pn, Py, etc. So this is your strong field ligand and weak field ligands. Clear?
यस सर
Should I go to the next?
यस सर
Okay. Now we will be coming to the crystal field theory. Actually, What is crystal field theory? Valence bond theory, that is the overlapping of the metal orbital with the ligand field orbital to form a covalent bonding. Once more, the field orbital of the ligand and the vacant orbital of the metal, they overlap together. Ligand will supply a pair of electrons to the metal atom. So this shows by your valence bond theory, and that forms a covalent bonding with the metal. But the crystal field theory, what is the difference between crystal field and valence bond? In crystal field theory, the total is a interaction, or that is the bonding between, that is electrostatic force of attraction. Here, CFT is ionic. Crystal field theory is the concept of ionic interaction of the ligand and metal. So here, point number 2, so ligand, what is ligand? Ligand either a point charge or point dipole. Point charge means the ionic ligand, for example, F minus, Cl minus, Br minus, I minus, जितना सारे नेगेटिव है, और are ionic ligand or known as the point charge. And neutral ligands, say for example ammonia, this is point dipole. Did you understand what is point charge and point dipole?
Yes.
एक ही जन बात बोल रहा है, yes sir. So anybody's doubt, please tell me what is point charge and point dipole. Point charge means the ionic ligands which are negatively charged, they are named as point charge, and neutral ligands like water, ammonia. So in water, so this is positively delta plus, this is delta plus, this is delta minus, containing a lone pair. So that's why it is known as point dipole. Clear?
Yes, sir.
Very good. So now we will be coming to the, when a metal atom, this is metal atom or ion, and ligands are coming in octahedral complexes. So this ligand are generally regarded as point charge or point dipole. This is their point charge or point dipole. So whenever they approach to the metal ion, when the ligands approaches to the metal ion, so what will happen? Just you think, what will happen? बताओ
Repulsion of electrons.
क्या क्या क्या?
Repulsion of electrons.
Very good, Ananya. There is a repulsion of electron takes place. Only repulsion.
So if strong ligand will be there, then pairing of electron will also take place.
Okay. So anybody other than this? Other than Ananya, if anybody can give the answer? Yes or no? Otherwise you pass.
Yes, sir.
So now, so here metal ion is positively charged, nucleus is there. Ligand either point charge or point dipole. So whenever a point charge, I am talking of point charge or point dipole, anything negatively charged. So there is a attraction or repulsion, Ananya.
Sir, attraction.
Very good. So there are two type of force is observed. One is an attractive force, another is a repulsive force. So attractive force takes place between positively charged nucleus of the central metal cation with the ligands. Ligand may be point charge or a point dipole. Both will attract. There are two type of force. One is a attractive force, and number two is a repulsive force. So kindly tell me those who could not follow the repulsive force, except Ananya. Ananya kept silent. So others please tell. So where repulsive force?
Between the ligands.
No, not between the ligands. The d electron of the metal. This is d electron. D electron is negatively charged, and this is point charge or point dipole. Among them, there is a repulsion. Repulsion between d electron and the point charge of the ligand. There is a repulsion. So when ligand approaches to the metal atom, the two type of force is observed. One is attractive force, another is a repulsive force. The repulsive force arises, so when a point charge and the d electrons, electron is negatively charged and the point charge is negative, or point dipole is also negative, so when they come, so there is a repulsion. Okay, so now so we will focus on the repulsive force. This is important. So which shows that crystal field theory. Crystal field theory is only shows the repulsive force between the ligand and the metal. So you tell, so when the repulsive force is maximum, so there is a complex does not form. So it should be minimum. Then only if the energy is minimum or repulsive force is minimum, then complex is formed. So now I would like to come for the next Any doubt you can ask in this page?
No, sir.
हमारी
Repulsive force.
हाँ क्या बोलो 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 पूछो
Repulsive force.
रिपल्सिव फोर्स कैसे हुआ ओके
Yes.
से fluoride it is negatively charged and d electron is your negatively charged, so negative repel each other or not?
Yes, sir.
For which a repulsive force, and we are focusing only for the repulsive force, which is known as crystal field theory. We do not focus on attractive force.
Yes, sir.
Clear? Now,
Yes.
next point, so d orbital. So this is the diagram of d orbital. In the d orbital, d is divided into 5 parts. So dxy, dxz, dyz, this is the diagram of different orbitals. Okay. So among the 5 orbital, this is called axial, this is called non-axial. Is it clear?
Yes, sir.
खाली एक ही जन बोल रहा है yes sir.
Yes, sir.
Everybody understood?
Yes, sir.
Yes.
So axial means on the axis, the lobes are on the axis, and here the lobes are in between the axes. So this is your non-axial. So these 3 are called T2G set. These 3 are called T2G. T2G, and this is called EG. There are 2 sets, EG set and T2G set. Okay, now, so you know this one. So now next I should come for the splitting. When ligand approaches in octahedral complexes, when ligand approach, so some ligands are approaching on the axis. Some ligand approaches on the some axis that is there on the axis, and other ligands are not approaching on the axis. So that means, so already you know that the dz square, this is your dz square. When ligand approaches to the dz square, so here, and so another is here dx square minus y square, dx square minus y square. This is called EG set. So whenever ligand approaches, so repulsion is maximum for EG set, because whenever ligand and the metal they approach, the ligand and the metal shows the maximum repulsive force than that of the which is not on the axis. Could you follow my point? थोड़ा ध्यान से सुनो. ये है, this is the orbital of the metal atom. Whenever ligand approaches to the metal atom which are on the axis, they experience the greater repulsive force. माने जो लोगन एक्सिस का ligand जो एक्सिस में आएगा, वो that will experience maximum repulsive force than that of the which is not on the axis. So hence the splitting of takes place, the splitting. So now splitting, so here you see, so this is the d orbital, when ligand approaches, so first it gets excited up, this is excited and degenerate orbital of D. Now they split up. Could you follow this one?
Yes, sir.
Or once more? Copy it, this one. When splitting takes place, the repulsive force of Eg will be more, so it will go above the degenerate state. So hence the energy is here 6 dq, or this is 2 by 5, 2 by, and this is will be below this one. This is your 4 dq. Copy it, this one.
Sir, what is DQ?
dq is that is 2 by 5 of octahedral. In the octahedral, there is a splitting. dq is your energy.
Okay, sir.
So 2 by 5 octahedral. Now, since Eg gets more repulsive force, it will go up, whereas T2G will go down 4 dq, and the total difference is there 10 dq. Or we can write this is 0.6 dq, 0.6 octahedral, or this is 0.4 octahedral splitting. 2 by 5, how much it is coming?
0.4.
0.4. That means this is total is 5. Out of this, 2 is going up, and 2 by 5 is this, and this will be 3 by 5. So this is 3 by 5. That means 0.6. This is 2 by 5. That is 0.4. This is for octahedral splitting. Copy it. Anybody's doubt, you tell me. This is your d orbital degenerate. Degenerate means having equal energy. So when ligand approaches, it gets excited. When it being more closer, they split into two parts, Eg and T2G. T2G will not experience the higher repulsive force, where Eg experience higher. Therefore, so it goes up and this comes down. And the energy gap between that is your 0.6 octahedral or 6 dq. This is 4 dq. Total is your 10 dq. This is for octahedral complex. Copied. तुम लोग का क्वेश्चन आएगा, ड्रॉ द ऑक्टाहेड्रल स्प्लिटिंग फॉर octahedral splitting, crystal field splitting of octahedral complex. Should I go to the next page?
Yes, sir.
Everybody copied?
Yes, sir.
Now come for tetrahedral complex. Tetrahedral. In tetrahedral complex, the same way, the d orbital degenerate d orbital when ligand approaches, it goes to the first excited state, still it is degenerate. Now, so whenever ligand approaches no ligand, the ligand which is on the non-axial position, that get more energy. Means in octahedral, Eg will get more energy, repulsive. But here T2G will get more energy. So hence, T2G will go up, Eg will come down. The difference is your 10 dq. Now the energy gap will be how much? The energy is there, this is 4 dq and this is there 6 dq. पूरा उल्टा. This is tetrahedral. Do you know why T2G will go up? Which the ligand, whenever it approaches, it approaches at the non-axial point. That non-axial will go up, whereas the axial will go down. Any doubt, please? Should I go to the next page?
Yes.
Or any doubt you ask me, right? Now we'll come for crystal field stabilization energy. Crystal field stabilization energy for octahedral and tetrahedral. For octahedral, crystal field stabilization energy is equal to minus 0.4 into number of electrons in T2G plus 0.6 number of electron in Eg. that is octahedral. For tetrahedral, crystal field stabilization energy is minus 0.6 MEg plus 0.4 N/T2G. This is your delta T, tetrahedral, and relation delta T tetrahedral is a 4/9 of octahedral. This is the formula how to calculate stabilization energy. Did you copy?
No, yes.
Yes or no?
No, sir. सर वो REL क्या लिखा है?
कहाँ लिखा है? क्या?
लास्ट में जो बॉक्स में REL क्या लिखा है?
रिलेशन क्या है? टेट्राहेड्रल और ऑक्टाहेड्रल डेल्टा टी मतलब टेट्राहेड्रल इज इक्वल टू 4/9 ऑक्टाहेड्रल.
Completed, sir.
Okay. Now distribution of electron. Distribution of electron in octahedral delta O means octahedral. In there are two cases arises for weak field ligands, and number two for strong field ligands. How to fill up the electrons in weak field and strong field. So in the weak field, so T2G, first electron, second electron, third electron is filled in T2G, followed by Eg, fourth electron, fifth electron. Then again it comes to the T2G, 6 electron, 7th electron and 8th electron. Next is here EG, 9th electron and 10th electron. So here Hund's rule are followed. Hund's rule is followed. And the energy difference is small. In strong field, T2G, 1, 2, 3, 4, 5, 6 electron will be filled at T2G, then it go to the EG, 7, 8, 9 and 10. So here the energy difference is high. And does not obey Ohm's rule. Did you understand?
Yes, sir.
Yes, sir.
Now I will explain completely how it takes place. So I am going to the next page.
Yes, sir.
Say for example, weak field ligands and strong field ligands. Okay, weak field ligands first you come. In the weak field ligands, D1, D2, D3, then D4, D5, D6, so we'll do. So first one in octahedral complexes. This is here for octahedral complex. In the octahedral complex, the diagram is here this. Now, D1, try to understand. Whenever d orbital containing one electron, so if it contains one electron, then so where to put? We have to put here. Okay, for a D1, now this is the case. T2G will get one electron. For D2, so it get two electron, 1 and 1. For D3, 1, 1 and 1. Could you follow or not?
Yes, sir.
ये वाला समझ में आया तो?
Yes, sir.
Now I will be coming for D4. D4 means total number of electrons are 4. So here, so first, second, this is for I am making rough one. 1, 2, 3, and fourth one will come at EG. 1, 2, 3 and fourth. So here I will be writing for D4 this is EG, this is T2G, D4. Copy it first. अरे सभी बुझलो कि नहीं?
Yes, sir.
Now I am coming for D5. इधर देखो D5. Come to the rough this side. 1, 2, 3, 4 and 5. So can you write D5 of your own? This is D4. D5 you write. Kapil, did you write D5?
Yes, sir.
Okay. Now, so similarly, so can you write D6, D7,
Yes.
D8, D9 and D10 for weak field? And dear student, please remember, so in the weak field, once more I repeat, so T2G, 1, 2, 3, then EG, 4, 5, then T2G, 6, 7, 8, then EG, 9 and 10. By looking this one, can you fill it up for D6, D7, D8, D9 and D10?
Yes, yes, sir.
अरे सीखी गलो ना नहीं?
Yes, sir.
Yes, sir.
हाँ सुनो थोड़ा और एक बार मैं रिपीट करना चाहता हूँ. सो नंबर ऑफ इलेक्ट्रॉन कहाँ देगा? 1 नंबर, 2 नंबर, 3 नंबर, ये जैसे लिखा है D1 में 1 ठो, D2 में 2 ठो, D3 में 3 ठो, जब D4 आया, 4th electron will go to the EG. Now D5 में the 5th electron will come to the EG. Now in the D6 में कैसे करेंगे? 1, 2, 3, 4, 5. Then 6 will come as a pair. 6 will come to the rough here. 6 will come over here. 7 will come over here. मतलब pair होगा. 8 will come over here. Then 9th will come over here. 10th will come over here. Is it clear?
Yes, sir.
Very good, very good, very good. Now, so crystal field stabilization energy. Now, for D1 कैसे निकालेंगे? D1 में ये 1 इलेक्ट्रॉन कहाँ है?
T2G.
T2G, the energy is decreased. ये वाला देखो, this is T2G, this is EG. So in EG, that is your 6 dq, and this is your 4 dq. Now since one electron is there, so I will be writing minus 0.4 into 1, that is minus 0.4 dq, or this can be written as 4 dq minus. ये वाला समझ में आया ना नहीं बताओ तो?
Yes, sir.
खाली एक जन बोल रहा है यस सर, आई एम नॉट हैप्पी.
Yes, sir.
ओके,
Yes, sir.
now I am coming for D4. How to calculate D4 crystal field stabilization energy? So इधर कितना तो इलेक्ट्रॉन नीचे है T2G में? 3. So minus 0.4 into 3 plus, so EG is your higher, that is 0.6 into 1. So this is your, जितना आया उतना dq, कितना आ रहा है देखो, this is your minus 1.2, this is 0.6, कितना आया?
Minus
Minus
0.6.
minus 0.6 dq, small dq, or 6 dq. समझ में आया?
Yes, sir.
So please find out D7 वाला. So D7 crystal field stabilization energy, or D7.
Minus 0.4 dq.
एक गोटे मिनट रहो,
4.8.
गोटे मिनट रहो आगे. D7. So 1, 2, 3, 4, 5, 6, 7. यानी कि T2G में कितना इलेक्ट्रॉन है?
5 electrons. 0.8.
D7. One, two, three, 4, 5, 6, 7. यही तो है.
Yes, sir.
So now crystal field stabilization energy is ये होगा T2G में जो रहेगा minus 0.4 into 2 2 4 into 5 5 प्लस इसमें 0.6 into 2. ऑक्टाहेड्रल केते होची?
Minus 0.8.
minus 0.8 dq or 8 dq. समझ में आया?
Yes, sir.
So similarly, crystal field stabilization energy from D1 to D10 you can calculate.
Yes, sir.
I have given in the which for a weak field
weak.
and for a strong field. Strong field configuration already given or not?
Given.
ସରିଲାଣି
हाँ ଆଉ 5 ମିନିଟ୍ ପରେ ସରିଯିବ।
ଆଉ ରେନକୋଟ ପିନ୍ଧିକି ଆସିବ ଯଦି ବର୍ଷା ହଉଥିବ।
ଠିକ୍ ଅଛି। Okay. Clear?
सर 8 DQ कैसे हुआ?
मतलब 0.8 DQ इसका 10 टाइम्स कर देना। वाह, this is equal to this 0.4 small dq or octahedral is equal to 4 dq. ये है रिलेशन। 0.4 is equal to 4 dq.
सर वो 8 -8 DQ होना चाहिए।
अरे हाँ, yes, you are correct. Minus. Who said? Pragya? Huh?
Snake.
Snigdha. Yes, this sign, the sign also you look. ठीक है. So, should I come for strong field?
Yes.
Similarly, we'll go for strong field. In the strong field, so already I have given ये वाला configuration याद रखना T2G 1 2 3 4 5 6. Okay, so it does not follow Hund's rule, and EG is your 7 8 9 10 does not follow Hund's rule, and the energy difference is high. Energy difference is high, and octahedral is greater than P, where P is your pairing energy. For weak field, delta octahedral is less than P. Follow Hund's rule. Please copy it. Then I will come for the calculation. Dear student, स्ट्रॉन्ग फील्ड का ये कॉन्फ़िगरेशन याद रखना जरूरी है। अगर नहीं रखेगा देन दैट इज ए प्रॉब्लम। अरे पूरा ठीक करे बुझलो ना नहीं स्निग्धा?
Yes, sir.
प्रज्ञा आसे ना आसेनी?
Yes, sir.
हाउ तो स्निग्धा ताको बुझेबू। Should I go to the next page? Time ହେଇଗଲା କୁହ। सरला कि
Yes, sir.
अरे किसी कहूना चुपचाप बच जाओ तुझे ओके नाउ आई एम कमिंग फॉर D7 directly D7 for strong field. So similarly, how to do T2G T2G and EG. हाँ बताओ केमिति कुह कई जने कुह फिलिंग करिबा
E2G 6, EG1.
हाँ 1 1 1 1 1 1 this yes or no this is
Yes.
D7 so what is crystal field stabilization energy बाहर करो तुम्हें एक्सप्रेशन टा कुह
Minus 0.6.
माइनस पूरा फाइनल आंसर पूछो
No, sir.
हाँ माइनस
Minus 0.4 into 6.
यस माइनस 0.4 इंटू
6.
इंटू 6 प्लस
0 into 1.
0.6 इंटू 1 कते आला
minus
minus 1.8.
माइनस हाँ माइनस
1.8.
माइनस
1.8.
1.8 of trilateral that is equal to minus 18 dq
sir minus 2 होगा
ये कितना हो रहा है 0.4 whatever you said only I wrote 0.4 into 6 that कितना ला 2.4 एटा ला माइनस एटा प्लस ठीक अछि
yes sir yes
बुझ पालो कि
Yes, sir.
so next class I will show the tetrahedral strong field and weak field on Wednesday. So tetrahedral strong field, weak field, and that is the stability constant, and that is the end of the chapter. बुझेला?
Yes, sir.
So should I stop the class?
Yes, sir.
So ଏବେ ପଚାରି ଦିଅ କ'ଣ ଅସୁବିଧା ହେଲା ନ ହେଲା ठीक है थैंक यू
Thank you.
okay sir will come right now